All right, we're going to go on and give some help to certify practice on section 7.4 in the new book. Now, I picked out a student randomly here, and this person had it wrong originally, but let's see what we can find out as we read it. So we have a bag of marbles. Well, there's 13 marbles, so that's our sample space. Now, 6 are red, 4 blue, and 6 green. And there's 3 with red and green on them. 3 red and green. How about an N here? There we go. Now, what are they asking? What is the probability that a randomly chosen marble has either green or red on it? And as we get ready for the Christmas season, that's very appropriate. Now, note that these events are not mutually exclusive. And you might say, why? Well, because there are some with red and green on them. So we're going to use the addition rule to start us off. What's the probability of picking out a red? Well, that would be 6. 6 out of 13. What's the probability of picking out a green? That's 6 out of 13 also. But notice now that some of them, 3 of them, have red and green on it. So this is a repetition. So we're going to have to subtract this 3 because it's already in here somewhere. So when we add this up, common denominators make it nice. This is 12. 12 minus 3 is 9 out of 13. And this person, of course, had it wrong. But there is the fractional display, and there is the decimal fraction display rounded to the nearest millionth. I don't know what this person did in preparation for doing this example, but you have a set of dice that are rolled. What is the probability that the sum of the numbers rolled is either a 7 or a 9? Now, it took me a few moments to make this little chart, but when there are 6 possibilities this way and 6 possibilities this way, 6 times 6 is a total of 36 possibilities. Now, you might be able to figure it out without making a chart, but a chart makes it so much easier. We want to have 7s. Well, there's 1, 2, 3, 4, 5, 6. And we want to have 9s. 6, 7, 8, 9, 10. So this will be 10 out of 10. That's a 10 out of 36. We can take a 2 out of each one. You always want to reduce the lowest terms. This will be 5 out of 18. And this person had it correct. Now, this one is a reading one where you're asked to pick out independent events. So, smoking cigarettes and getting lung cancer, are they independent of each other? No, they are connected, so we didn't choose that one. The destination of 3 randomly selected travelers at an airport. Well, as long as they're not on the same plane, these would be independent events. So we check that one. Winning a marathon and winning a local lottery. These would be independent events. Now, how about winning a marathon and running 5 miles every day, if that's what it was? They would not be independent events because one is training and ties in intimately with the other. Flipping a coin and getting a heads twice in a row. Again, you're using that same coin. The first time you do it, it's independent. The second time you do it, that's independent. Now, one of the other common ones, since this is a review, is if you had a jar and it contained colored balls. Some were red and some were blue and some were black or whatever. And you take out one ball and then without replacing, you take out a second ball. Now, would these be independent events? And the answer would be no. Why not? Because by taking out the first ball and not replacing it, made these fewer. So they are related. Now, if you return the ball and then pick out another ball, those would be independent events. Just like if you have cards out of a 52 card deck and you pick out one and then return that card to the deck, pick out another, those would be independent. But if you don't return that card, now instead of being 52, there's only 51 because you've taken out one. Those are not independent events then. All right, just a little review. We don't know what questions you're going to have. Now, this next one deals with a survey. They're giving you a chart. And again, you're going to have to pause, read it carefully, and then you're looking for a strategy to get the answer. Well, here we show breakdown of both faculty and students in a recent study about restructuring the campus to include an honors college. Find the probability that a randomly selected person is either a student opposed. So let's look at our chart. Which are students opposed? Right there. To the change, or a faculty member who has an opinion either for, well, the ones in favor, or against. All right, so these are what we're looking for out of our sample space, and we know that that sample space is 205. So if we add up these three groups, this adds up to 69 over 205. And that's just as easy as it is. Okay? Again, you have to read it carefully and be sure you are answering what they are asking. Again, something like this, you're going to have to read it carefully. Use the following table to find the probability that a randomly chosen member of the Student Government Board is a freshman or lives in off-campus housing. So let's look at our freshman here. We have this is a freshman, and then we have students that live in off-campus housing. So what we need to do is add this up. This is going to be 3, 4, 6. We're going to add this up now. This is 5 and 6 is 11. So our sample space now is 17. You see where we're getting it from. Now, freshmen, there's our freshmen. Now, we don't have any freshmen living off campus, so that's 3. And then we're going to add those students living off campus. That's 6. So 3 and 6 is 9. And that's the answer. Now, if we had somehow a total of freshmen, and there was a possible repeat somewhere, not here, but if there were, that's what you'd have to subtract so you don't have repeats in your probability. All right, let's go on. Now, we had one like this in our quiz where we had the word Mississippi, but here the letters are senses. We see how many letters there are. 1, 2, 3, 4, 5, 6. So our sample space is 6. What is the probability of choosing an E or an S? Well, how many S's? We have 1, 2, 3. How many E's? 1, 2. So we have 3 S's and 2 E's. That would be 5 out of 6. This one is almost too easy. But that's the protocol, the strategy for getting it. Find out your sample space and then what are your possibilities, the ones that you want to select. All right, we did one like this, so another chance. We're going to select a student government board member that's a senior. So who are our seniors? We have seniors here. Or lives on campus. All right. So now we don't have any seniors there. So if we did, we would have had to select that. But since there are none, that makes it a little easier. And we want to have those that live on campus. So let's get some totals here. 2, 4, 7, 9, 10, and 7 there. So our sample space is 17. And since we want a student that lives, a senior, or students that live on campus, this is not repeated, so this is just going to be 10 out of 17. So again, not too bad. Again, there are different examples of what you're going to get, but these you might get some of the same, but the strategy for doing it. Now we want to see independent events. Winning a marathon, winning a local lottery. Well, we had that one already, so that's an independent event. The favorite fruit of 5 randomly selected shoppers in the produce department. Well, there are different shoppers. That would be independent. Pulling a red marble from a jar. Okay, we talked about this. And then pulling a second red marble from a jar. Here, and here's the key word, without replacement here. Now, without replacement makes that a different environment. So, in a sense, they're related because you've taken out one, you've changed the environment by taking that one out. Now, if you were to replace it, then they would be independent events. All right, here selecting an A and then an S from a pile of face-down letters, tiles without replacing the first tile. Again, the key here is without replacing. Now, if you did replace it, it would be independent. Without replacing makes it not independent. Let's go on. Again, I think this is our last one, so let's check it out carefully. It's similar to what we've done already. We have a table. We're going to have faculty and students survey about restructuring the campus to include an honors college. Find the probability that a randomly selected person is either in favor or opposed. Now, they're not distinguishing now between faculty and students. Here they're just in favor or opposed. So in favor, if we add them up, that's 63, I should say. Opposed is 61. So we add these two up, and that's going to be 124. And we already have our total here of 197. Again, you may have one that's a little different. This one seemed rather easy, although it was listed as medium. 124 over 197, and that seems pretty straightforward. And that would wrap this up. Again, if you have questions, and unfortunately now MATLAB is closed, but if you get stuck on something, you can actually email me, and if I have time, I'll try to get back to you with a little short video presentation. All right.